Have you ever looked at a tangled cord and felt frustrated? The universe is full of tangles too, but these are magnetic flux ropes, powerful ropes of pure energy. We see these same structures in our labs and stretching across space, linking tiny experiments on Earth to cosmic events among the stars. The laws of physics are the same everywhere, from a small lab to a giant star. So, what is a magnetic flux rope? Imagine invisible lines of magnetic force, thousands bundled together, twisting and braiding like a rope. This structure stores immense energy, tiny in labs, but in space they can be bigger than our planet. They erupt from the sun, stretching into the solar system, carrying energy and charged particles. These ropes are dynamic. As they twist, they store more energy, like a rubber band wound tight. Eventually, the energy is released in a violent explosion, magnetic reconnection, one of the universe's most powerful events. This happens on both the smallest and largest scales. Understanding these structures is like finding a universal language, a pattern nature repeats everywhere. When we see a tiny flux rope in a plasma chamber, we glimpse the same physics that powers a solar flare. The same rules that create a spark in a lab also create the aurora borealis. The universe is whispering its secrets to us. We just need to learn how to listen and observe these beautiful, tangled threads of energy. How do we study something that happens on the sun? We bring a piece of the sun to us. Scientists use special machines to create plasma, the fourth state of matter, a superheated gas that conducts electricity and creates magnetic fields. By shaping and confining plasma with magnetic fields, we create miniature magnetic flux ropes in the lab. Inside a vacuum chamber, plasma twists and pinches itself, naturally forming rope-like structures. High-speed cameras and magnetic probes let us watch and measure the energy building up. We can even force the rope to snap, studying magnetic reconnection up close. These experiments test our theories about the universe. If the rope behaves as predicted, our theory is stronger. If not, we revise our understanding. This is the heart of the scientific method, a constant conversation between theory and experiment. In space, we're just observers, waiting for the sun to flare. In the lab, we're in control. We can change the magnetic field, the plasma density, and repeat experiments for accuracy. This precision helps us decode complex data from space telescopes. The tiny ropes we make on Earth act as our Rosetta Stone, translating the language of the stars. Now let's travel to the sun, a gigantic ball of churning plasma, its surface a chaos of powerful magnetic fields. These fields get stretched, twisted, and tangled by the sun's rotation and bubbling hot gas. Huge magnetic loops, enormous flux ropes rise from the surface, holding incredible energy. Sometimes these ropes become unstable. When they reach their limit, they erupt in a solar flare, a tremendous explosion. The flux rope can break open, hurling a colossal cloud of plasma and magnetic fields into space, a coronal mass ejection, or CME. These are the sun's great storms, born from the snapping of braided magnetic ropes. A single large CME can release the energy of billions of hydrogen bombs, sending charged particles racing across space. Sometimes they head straight for Earth. This is why studying flux ropes matters. They affect our daily lives. By observing the sun, we can see these ropes form, twist, and grow unstable, giving us a chance to predict solar storms. It's like being a cosmic weather forecaster, predicting the eruptions of a star. The connection between lab-sized flux ropes and solar giants is profound. In a lab, a flux rope might last a fraction of a second. On the sun, it can exist for weeks and hold unimaginable energy. Yet the underlying physics, the braiding, twisting, and explosive release, is the same. When a solar flux rope erupts and sends a CME toward us, it creates space weather, a storm of magnetism and radiation. When this storm hits Earth, it interacts with our magnetic field, creating the aurora borealis and australis. But the effects aren't always beautiful. Strong space weather can overload power grids, damage satellites, and disrupt communications. Astronauts are especially vulnerable to increased radiation. That's why understanding and predicting magnetic flux ropes is critical. Our modern world depends on these cosmic braided structures millions of miles away. So, next time you see the northern lights, think of the tangled threads connecting us to the sun. The universe is filled with hidden patterns, fundamental rules that repeat everywhere. From a spark in a lab to a star-spanning tempest, the story of magnetism is woven throughout the cosmos. The journey to understand it is one of science's greatest adventures, inviting us to keep looking up and marvel at our universe.